Okay, so 8.1. We're going to do domain and range, and we're going to do functions and just all kinds of different things in between here. Very first thing they're going to throw at you in 8.1 is they're going to stick with domain and range, and then we'll build up to the function part of it here just a little bit as we go along. But the first thing they're going to ask you to do is they're going to ask you to find the domain and range from an order pairs. And if you don't know what domain and range are, before we go any farther, we got to tell you what that is. Domain is basically your X values. And sometimes they like to get fancy and call that the input values. But really the main thing is that's your X values. That's what you're plugging into the function. The answer you get out of it is your Y values. That's the range. And they call that the output because once you plug the numbers in from the input, well, then you get the answer out of it, and that makes it the output. So when you're looking at the different parts of it, that's what we're looking at. Domain is your X values, the range is your Y values. So here's what we're going to do. We're going to give you a list of ordered pairs. And when they give you a list, they just call it T for order pairs. They can call it any letter. Doesn't matter what you want to call it here. Let's say -9 there. That's terrible, -9. Let's try that again. Okay, so give everybody a second to get those copied down there. Okay, so here's a set of ordered pairs, and they're going to ask you to state the domain and range. Or the domain and range, whichever one you want there. Now, the one thing they're going to tell you is when you state the domain, they're going to ask you to do this in set notation. And all that means is you're just going to give me a list of numbers in order. Just list them out. There's no ordered pairs or anything. It's just a big chunk of numbers that you're going through. All right, and we do the domain. That's just the X value. So tell me every X value that shows up in your list. So your domain is, you're going to have little squiggles here, and just go back and list the numbers. It's -2. Nope, not -1. +1. We've got a -6 and a -9. Now, if you want to put them in order, that's fine. As long as you've got the numbers listed, that's all that matters. Range. Well, that's the Y values. It's -2, -9, 9, and then 0. Okay, and that's it. That's all you have to do. And they're just getting you to separate the two parts out to realize that an ordered pair is basically that. It's a set of X's, it's a set of Y's, domain's your X's, and then the range is your Y's. Okay, so once they give you that, again, they'll just give you a list. That's technically a relation. It's just a bunch of ordered pairs is all that is. But here's your set. And probably needed, depending on how they give to you, this case they had 4. Sometimes there might be 5 or 3. But just go back through and list all the different X's and all the different Y's. If you happen to get one that repeats, if you'd had a -9 and a -9, if a number repeats, you only have to write it once. So if you'd had a -9 here and a -9 here, you would have had to only list it one time. So you don't have to list it twice. Okay, the next thing they'll do, same setup, but they're going to give you a graph where you've got just ordered pairs, and you're going to go back and list the domain and range from the ordered pairs. Now, obviously, theirs look better because they'll have the grid lines in here. And we'll have to go back and actually answer in the question. Okay, so there's 4 different order pairs. In same direction as the other one, list the domain and range and list those in set notation. And even from the order pairs that you have on the graph, you still pretty much would do it the same way, that you go back through and just list off the different values of the order pairs. Well, this one would be 1, 2, 3, 4, 5. So that order pair would be at -5, 1. This would be at -4, 0. This is at 1, 0. And this would be at -1, sorry, yeah, -1, -2. So if they give you the dots on a graph, just go back and tell me what that ordered pair is, and just so you don't have to worry about it in your head, just write them all down. And then it's still the exact same thing. For the domain, well, it's your X values. Just list these right here. It's -5, it's -4, it's 1, and it's -1. You know, if you want to be order and put it in least to greatest order, you can do it that way too. Okay, for the range. Now, purposely pick these problems because you've got 1, 0, 0, -2. The 0 repeated. You don't have to write it twice. So you can just put 1, 0, and -2. If you put it twice, it should be okay. And if that's the case, they may tell you, well, your answer is correct, but you put in an extra value that you didn't need. So that, you know, either way you go, as long as you've got the different numbers listed, then it should be okay. Okay, and 8.1, that's it. It's just an introduction to domain and range. They're getting you ready for functions, which is coming in the later part of Chapter 8. Kind of building up to it there. And we're going to, instead of starting another page, we're just going to go ahead and put 8.2 on this one as well. Okay, so 8.2 is where they jump from having you just tell me what the domain and range is, and now they're going to tell you, all right, based on the information you have here in your domain and range, is this thing a function? So they're going to ask you to identify functions off this part. Now, before you do this one, we're going to break it down and tell you what it is that makes a function a function. And we'll put it in layman's terms, because if we give you the definition that the book or the textbook is going to give you, it's not the best one in the world, so let's just give it to you in the plain English definition. For functions, cannot have repeated x values. And again, if we stick with the last part we did in 8.1, that you cannot have repeated domain values. Same thing there. And basically, you think about functions, they're experiments. If you're baking a cake and you add the same amount of flour and milk and eggs and butter and everything and you mix it up, and one time you get a cake and the next time you get a souffle, that's not a function, because the function basically says if you do everything this certain way, you should get the same thing back every time. If you get one of these and you get one of these, it's something different, it's not a function. Vending machines, those are function machines. You push a Mountain Dew button, you should expect to get a Mountain Dew, right? If you get a Mountain Dew or you get a Dr. Pepper, I'm not going to be very happy because I don't like Dr. Peppers. So a function machine says if you push the button, you get one thing and you get one thing only. If you do this one thing, you get the same thing back every time. Okay, so with the different things, they're going to show you all kinds of different things, and they're going to ask you, is this thing a function or not? And basically, again, if you have one x value that has two different options coming off of it, it's not a function. It's got to be a one-to-one thing. So, okay, and let's just show you some of the different options of what you can do here for this thing. Because they'll list these off 2 or 3 different ways. Show you one where it is a function and show you one where it's not a function. Just so you can see the difference of the two. Okay, now, and depending on how they'll set these up, sometimes they'll use arrows, like they'll have 4 going to the cloud, 1 going to the rock, 3 to the desk, 2 to the moon, or they may just give it to you as a set of ordered pairs. It may look something like that. Now, what we'll do is we'll do one more over here. Okay, so here's 2 different examples where sometimes they use arrows, sometimes they use just order pairs in a box form. They'll show you all kinds of different ways on this one. But here's the thing. Here's all that you're looking at. And here's what you have to kind of key on. When you're doing this one, whichever problem that you're going to do, domain and range, if you notice back up here in the definition, didn't say anything about the range, right? Just ignore the range. So whenever they give you this part, just forget about it. It's gone. I'll put it back in a second. All you're looking for is, does the x value repeat? Right here, you got 1 going 2 different directions, right? It could be this or it could be this thing. So if you ever see an x value, take that thing out there. Oh, sorry, I got too much. If you ever see it where it's got more than 1 arrow drawn away, what it's going to do, and if you think about it like in ordered pair form, this one would not be a function. Because if you think about the ordered pairs, you could have 1 and a rock, or you could have 1 and a desk. So there's where you've got the repeated value, because this 1 goes in 2 different directions. And that's all you're looking for. So domain value, if you've got 1 value here, if it's going 2 different directions, it's not a function. If that had just been that part, would have been okay. But as soon as you draw that second line from here to here, that makes it not be a function. For this one, again, you don't really care what's happening in the range. You could take every single number here and make all these out to be 5s. But -4 goes with -1. The 3 goes with the 2. The -1 goes with the 5. The 9 goes with the 5. Nothing repeated. So that one would be yes, it is a function. Because none of the x repeat. Over here, the 1 repeats. So that makes it out to not be a function. So whenever you're doing these, you can only have one x value for everything that goes with it. Now, it may be that, and here's sometimes one that throws you off, and I'll see if we can make this one a little bit quicker than some of these other ones. Everybody good on those? Everybody still copying that? Okay. Here's one that sometimes throws people off just a little bit, and we'll make this as quick. We won't put any boxes or anything here. Because this problem sometimes throws people off just a little bit. Because everybody's like, well, it can't be because everything's pointed to 5. But again, when you do this one, you don't even really care about this part back here. You're only looking at the domain. 4 has 1 arrow. 3 has 1 arrow. 2 has 1 arrow. The 1 has 1 arrow. So for this one, it is a function. Doesn't matter what's happening in the range part of it. It's just the domain. So as long as nothing repeats here, we're good to go.
You just making sure that on a graph form with lines don't touch each other, or at least not directly. Because if you had an x factor going in a certain direction, like if you just drew a line based off that number, it would just go.
Well, and yeah, that's coming back to what they call the vertical line test. That's actually coming up here in just a minute, so we'll show you that one, which is actually the next thing up here. Okay, so to kind of spin off that one, here's one where they talk about more graphs, and this is what they're going to have you use the vertical line test. Okay, and here's where you can be an optimist or you can be a pessimist on this thing. No, still 8-2. So vertical line test. If a vertical line is drawn through the graph, and it intersects in 2 or more points, it is not a function. So we'll kind of use that definition like we did on the other part. That when we talked about what functions were, and again, they give you all kinds of definitions, but the easy way to think about it is functions, you cannot have repeated x values. And the vertical line test is just it's a graphical way to show whether or not you have repeated x values. Because if you draw a vertical line and it hits it more than 2 more times, that means you've got the same x value in 2 different places when you're going through these. And they'll show these graphs a bunch of different ways. So let's just kind of give you one that's, we'll just give you time to start off with here first. Okay, so there's the first example. I'll give you a parabola. And if you start drawing vertical lines through it, we'll use the green here. Draw that. How many times does it hit the graph? Just once, right? So that one's good. You can draw as many vertical lines as you want to. That one hits it 1 time. No matter what you do on this thing, it's going to hit it one time every single time. So that one would be okay. That's a yes to that. They ask you, is the graph a function or not? Well, and again, you can draw 1,000 vertical lines. If everyone only hits it one time, you're good to go. Now, on the flip side, turn it this way. Mm-hmm. Yeah. Now, hits it one time, we're okay. Hits it 2 times, we're okay. It's like this one. If you went on the very edge right here, you could draw it so it skirts by and hits it one time, right? But what happens if you draw it anywhere back here? So, not a function. There you go. Because if you were to go back and graph this line, if we put an XY axis back on here, if you put an XY axis on this line, where you're hitting the line once here and once here, if you went back and graphed this line, we went back and put some numbers on this thing, this point would be at 3, 3. Sorry, 2, 3. This point would be at 2, negative 3. And that's all a vertical line does, is it's a check to see, okay, did you use the same x value twice? So anytime you use a vertical line, it's always going to be that same thing for the x value. And you're checking to see, did I get 2 different y values or did I only get 1? And if you get the line twice, then it's not a function. Now, what they're going to do for some of these is they'll actually give you some lines or give you a graph where it's just ordered pairs. Or something like that. And they'll ask you, do those points represent a function? Well, again, just think about what you would do here. You just go back and draw a vertical line. Draw it here, only hits that line, so that one's okay. If you draw it here, only hits that line, that one's okay. So no matter where you draw it, you're only going to hit it one time. Oh, same thing here, that one only hits it one time. So no matter how many times you draw it, you're only going to hit 1 point. So that one would be a yes. Now, where it would be a no, if you had something like that. Again, we don't really care about what the values are. You're just looking at numbers. So go through the same thing again. Draw a vertical line here through this point, only hits it one time, it's good to go. Draw one here, same thing, hits it one time, it's good to go. That one's okay. But when you draw this one, hit it twice, hit 2 points. Because you hit those 2 points, that one's a no. It doesn't matter about all the other points that's out there, but if you can draw any vertical line to make it hit 2 or more points, it's not going to be a function. No matter how they draw the line, no matter what they do with it. Okay, and about the only other thing I can think of that they might throw at you that might be a little bit, oh, not that one. And this is where they try to get just a little bit tricky on one like this, is they give you 2 horizontal lines where one has an open circle on the end and the other ones are all kind of closed circles. But don't let the circles throw you off, because again, if you draw a line right through the middle of both of the graphs through here, there's 2 times where you hit the line, so you're okay there. You could draw another one back here. There's another one, you hit it 2 times. You can draw another one back here, hit it 2 times. There's all kinds of vertical lines you can draw anywhere in this area that you'd hit it 2 times. Doesn't make it enough. So, with the vertical line, that's all that you're looking for is just draw the vertical line. If it hits any 2 points, it's a no function. If it hits 3 or more, it doesn't mean you can hit 3 or 4 times, but as long as it hits 2 times, then it's not going to be a function. Okay, so once they give you a couple examples with that one, just making sure you got it. The next objective that they give to you is they kind of say, all right, we've got the vertical line test, we've got the definition of functions. They're still kind of walking you up to this one. And next thing they're going to ask you for is they're going to ask you to complete the function table. Now, one thing they kind of do on this one is they don't really set this up here. But we'll do this on the side. Because they talk about doing a function table, but they don't really tell you right off the bat what a function looks like. So let's talk about function notation. Okay, so let's go back to something we were kind of used to doing here in the last little bit. In the last part when we were graphing lines in chapter 4, we were graphing y equals mx plus b form. You know, you've got your slope, you've got your intercept, that kind of thing. Here's basically what function notation does. That you take y equals mx plus b, you're going to replace the y with f parentheses x. And that's, when you read this f parentheses x, that is f of x. That is not f times x. So instead of having an equation would be y equals mx plus b, if you think about equation form, function notation is going to be f parentheses x, or just f of x equals mx plus b. They do the same things. They work the same problem. They go through everything. The only thing you're going to do different is instead of having the y equals, you take out the y and replace that with f parentheses x. It's the same setup. It's the same notation. It works the same way. You plug in the numbers. You work through everything. You do everything you can do for these. Now, before we do the table, let me show you just one function to have you plug in one value, just to kind of walk through this one, because before we do 6 values, you need to know how to do 1 first. Okay, so here's what they're going to do. Something like this is they're going to give you, again, we're just going to do one number first, then we'll actually give you a table and plug in a bunch of numbers. That they're going to give you f of x is 2x plus 3. And they're going to tell you to evaluate f of negative 4. And all that means is that you're going to replace x with negative 4. That's all that means out of this equation that you have. So basically, it's kind of like what we were doing in the earlier part. If you're doing y equals mx, you know how when we were solving equations and we got the answer x is equal to negative 4, and we just plug it back into the equation? That's what you're going to do on this one is you're going to take this negative 4, and everywhere you have an x, you've got to put negative 4 in its place. So if f of x is 2x plus 3, easiest way to do a problem like that is wherever they give you this equation or this function that's here, and then they tell you to evaluate the number, just put that number underneath it. And then everywhere you have x, just replace it with negative 4. Everywhere you have an x, replace it with negative 4. Okay, so on the right-hand side, you've got 2 times negative 4. That's negative 8 plus 3. And then negative 8 plus 3 is negative 5. Now, and with a problem like this, you don't do anything to the left-hand side. That is your answer right there. Because you're looking for an ordered pair answer. That you started with -4, and when you plug -4 into this equation, the answer you get, which is basically like the y value, would be -5. So that's your domain, that's your x value. This would be your range. That would be your y value of -5. Because sometimes people will work this problem out. They'll get everything here, and then they'll go back and divide by -4 because they're thinking it's multiplication. But remember, it's not f times x. It's just saying this function we have, we're going to plug in this value for x, and then we're going to work it out and see what we get when you're going through this thing. Okay, so it's the same way as evaluating that back here. They would have said, plug in or find y. Basically, this is how they would have said it back in the earlier chapters. For a problem like this, they would have said find y when x equals -4. And then they would have given an equation, like we had here. They give you that, you take the -4, you plug it back in. It's just a shorthand way of saying that same thing. So now we've got this function, and instead of saying plug in -4 and evaluate for y, it's just find f of -4. There you go. So take out the x, put in -4, and then work it out. And you only work out the right-hand side. You don't do anything to the left-hand side. That's just the notation of it. Okay, so that's what they would want you to do if it's just one value. You take out the x, plug in the number, and work it out. And then what they're going to do then is they're going to give you a table of values where you're doing not just one number, you're going to do like 4 or 5 numbers. Oh, that's crooked. Okay, so for one like this, and this is where you actually get a full table to do. They'll give you a table, and they're going to tell you to plug in these numbers, and then plug these numbers in, and then work it out and tell me what you're going to get. Okay, so all you're going to do is, everywhere you have x, you're going to plug in -2. So same thing here. Instead of having h of x, we're going to have h of -2. But really that means we're going to do 5 times -2 plus 1. Because basically we're just starting with this equation. So everywhere you have x, you're going to take out the x and replace it with -2. Okay, so 5 times -2 is -10. Plus 1 makes it out to be -9. That's what we'll put in there. Okay, this time they want you to take x out and replace it with 0, so it's going to be the exact same thing. This time we're going to plug in 0. So it's 5 times 0 plus 1. 0 plus 1, so that would just be 1. And then just keep on going from that. Next time you'll plug in the 2. 5 times 2 plus 1. 10 plus 1 for 11. And then just keep rolling through all the numbers that they give to you. Okay, so with the chart, with the table, they still give you the equation. Just it looks a little bit, and again, a function is just a fancy equation. It has certain characteristics of what it does. And this is the number they want you to plug in, then you just tell them the answer that's here. And again, you don't do anything to the left-hand side. It just kind of holds the notation of it. Everything you're going to do is just to the right-hand side of the equation, and that's why we're just working out one part of it there. Kind of go through the numbers of it.